So I take also the chance to thank all my co-authors, in particular Enzo and Elia, that are two undergraduate students that did most actually of this work. So we all have this experience of collecting music and create such called playlists, to which normally we give titles. And this title normally can reflect the style of the music that is in the playlist, or the purpose of that playlist, or the mood and emotion, or whatever. But there will be still a small part of the title that we can think that do not follow in any of the categorization that we can find also in literature. And looking at real title names from the data set that we can have, we can conclude that playlist names are not necessarily bound to a category. The user has total freedom of expression for realizing the playlist title, and we need still to handle this kind of variability. And things are going even more complicated because with the generative AI, there are websites like this one that with the motto, no more playlist names, is creating not trivial titles like My Therapist is a Song, or When Life Gives You Lemon, Make Lemonade. And we still want to answer the question, for this such playlist title, what are the best tracks that we can recommend? So the goal that we have is to generate a playlist using only its title that we can use for both cold start recommendation and automatic playlist generation. Of course, this is a challenge because the natural language here will not depend on a set lexicon, and there will be high variability in playlist titles. We will rely for this research on the Million Playlist dataset initially released by Spotify for the RecSys Challenge 2018 that contains 1 million playlists and over 2 million tracks. In literature, you can find a lot of works combining NLP on music recommendation. The real difference with our work is that we focus mostly on playlist title used as an input to recommend for the recommendation. And the real work that actually did this in the past were those from the RecSys Challenge 2018. That will be the works to which we will compare our approach. That is composed by two parts. The first one, a fine-tune language model, and the second one, predict with semantic similarity. So the main idea of this is that as in word embeddings, words occurring often together in sentences will get close in the embedding space when we do compute embeddings. Also in this work, the titles of tracks occurring often together in playlist will be close in the embedding space. Of course, this is a simplification. Instead, in the detail, what we do is we have our data set. We use a pre-trained sentence BERT to realize playlist embeddings computed on strings of playlist title and all the tracks title that are contained in that playlist. These embeddings, we cluster them in a homogeneous group of playlists containing more or less basically the same songs or similar songs so these are more or less homogeneous, but there is also some more heterogeneous clusters. For example, we call these Michelin clusters that contains a bit of everything, and we remove this kind of cluster to not produce noise in our fine-tuning of a language model. Also, in this case, this is a transformer-based sentence BERT. In the phase 2, we have our fine-tuned language model. We use it for realize embeddings of known playlists from the dataset. And every time that a new playlist title arrives, we embed in the same way. So that now we can compare and we can rank the known playlist on the basis of cosine similarity with the new playlist title. We select the most relevant playlist, and thanks to a voting mechanism, we can extract and recommend the most represented, most popular song in this subset of relevant playlist. We evaluate it both quantitative and qualitatively. Looking at the quantitative evaluation, we compare, as I said before, two works from RecSys Challenge 2018 and we have in both metrics, this method is overperforming these works. In particular, in the fine-tuned version of our work that has been realized using cross-entropy loss. Moreover, we performed a qualitative evaluation in which two human annotators basically were having a playlist title, for example, Rock Classics. The system were recommending song, and the annotators decided that Celine Dion is not matching this rock classic playlist, and AC/DC and Nirvana, yes, they are. So this evaluation has been done on a subset of 22 selected playlists, and the score is basically the ratio between the number of valid tracks and the total recommended tracks. Also in this case, the results confirm that the best variant is this one fine-tuned with cross-entropy. We did a very preliminary first experiment with LLMs, just trying to predict with a prompt. The prompt was setting a persona, give precision instruction, include certain number of examples from 0 to 5, and ask for a specific output. So these results are very preliminary. But what we realized is that GPT-4o in particular was super good in the qualitative score, but the fine-tuned version of our method was still good, better on quantitative metrics. Of course, this is super preliminary. Okay, so to conclude, we realized this pipeline for playlist generation from titles only that outperforms the state-of-the-art on this niche. And we did this first assessment of prompt-based LLM. For future work, we want to mitigate popularity bias, use this in place continuation and in hybrid system. I leave you with these slides in which there is a QR code to download the presentation with all the links and the invitation for our demo that will be on Thursday. Thank you.
I read the paper with interest, so that's really interesting. And my question is, you mentioned that there's sometimes very broad, generic playlist titles also. Can you say something like how, did you include that human assessed that or not, and why? What are the reasons?
Thank you. So, yes, so there were some clusters that were super generic, and this was clearly visible by measuring basically the distance between the center and all the playlist. We didn't include them in the fine-tuning because these were not really homogeneous clusters. So a fine-tuning on this document was not learning anything interesting. Instead, such playlist with generic names actually can be used for the inference space, basically, for the prediction. So these are part of this, will basically attach the most similar playlist names anyhow, and so they will be still usable, basically, for the prediction and the recommendation.
Okay, thanks. And was this a large proportion or like small proportion?
Was quite a large proportion. It was 30 to 40%. I don't remember the exact number. I think it's in the paper, but was quite an interesting number of clusters that went out.
Okay, so potential for future research.
Yes.
You have a question?
Thank you for your job. Actually, I have a question. Maybe you have an explanation why triplet loss shows worse result in your case, some insights?
So actually, I agree with you that if you think logically, triplet loss would have been given a better result because it's done for that. We have not a super clear explanation in the sense that we were expecting the reverse, but it's probably too much learning the specificity of the data set. And so the cross-entropy makes the approach, the model, the fine-tuned model more generic, and so is performing better on this.